In this titration problem, we see that it's going to take 34.62 milliliters of a 0.300 molar magnesium hydroxide solution in order to neutralize 15 milliliters of hydrochloric acid solution of unknown concentration. And the question that we're trying to solve is, what is this concentration of the unknown hydrochloric acid solution going to be? The very first thing we need is a balanced equation. So this is a neutralization reaction between HCl, hydrochloric acid, and magnesium hydroxide. When we write this equation, we see that we're going to need 2 waters and 2 hydrochloric acids, so coefficients of 2 in front of the HCl and the H2O. The magnesium compounds are fine with just the 1 for the coefficient. So the first step is to figure out, in that 34.62 milliliters of magnesium hydroxide solution that was delivered via the burette, just how much magnesium hydroxide was actually dispensed into the flask containing the unknown hydrochloric acid solution. So to find this, we need to take the volume of that stock solution, the titrant, and multiply it by the concentration of the titrant. So 0.300 moles magnesium hydroxide over 1 liter, that's your concentration, times the liter equivalent of the volume, and the volume must be expressed in liters in this step in order for it to cancel out with the volume units of molarity. With proper sig figs, this would come out to 0.0104 moles magnesium hydroxide. Once we know how much magnesium hydroxide was delivered to the analyte, the hydrochloric acid solution, now we need to use the mole ratio, which is established from the balanced equation, to help us figure out how much hydrochloric acid was neutralized by the addition of this magnesium hydroxide. So we take that magnesium hydroxide amount, 0.0104 moles, and we multiply it by the ratio of the hydrochloric acid to the magnesium hydroxide. And based on the balanced equation and the coefficients, it's a 2-to-1 ratio. And so this means that we actually neutralize 0.0208 moles HCl. And that's how much HCl was in the flask, the unknown solution, at the beginning of the titration. So now, to determine the concentration of that HCl solution, we need to take that number of moles of HCl that was present and divide it by the original volume of that solution, which was 15 milliliters. Once again, we want our concentration units to be in molarity, so we have to make sure that the units are moles over liters. So 15 milliliters converted to liters would be 0.0150 liters. And when we solve, you should come up with 1.39 molar HCl. Remember that capital M stands for molar, which is the same thing as moles per liter of solution.